Now for this part then, we've got to work out the probability that 2 bags contain more than 53 kilograms and 1 bag less than 53 kilograms. And to do this, what I imagine is a tree diagram, something like this. I wouldn't necessarily draw this, but I can visualize this in my mind. So I've got the 3 bags, okay, and the first bag can either contain more than 53 kilograms or less than 53 kilograms. And then we look at the second bag, and again it can contain more than 53 or less than 53. More than 53, less than 53, and so on. And the same applies for the third bag. Now we found out these probabilities, or I should say we found out from the first part the probability the bag contained more than 53 kilograms. It was 0.0668. So clearly the probability it's less than 53 kilograms has got to be 1 minus that value. It comes to 0.9332. So we know these probabilities now. So how do we work this out? Well, from the tree diagram here, we can see that to get, say, 2 bags that are more than 53 and 1 that's less than 53, you could take this route, for instance. First bag's more than 53, second bag's more than 53, and the third bag is less than 53. And if you were to work that out, you'd be doing that this would equal this one times this one times this one. In other words, 0.068 times 0.068 times 0.9332. So if we just pop that in there, we've got 0.0668 squared, okay, because we repeat the multiplication across here, multiplied by 0.9332. But it doesn't end there, because there's not just this route through the tree diagram, there's another route. You could, for instance, have that the first bag was less than 53, but the remaining 2 were more than 53. When you do this sum, it's going to actually be the same as this sum, only in a different order. 0.9332 first of all, multiplied by 0.0668 squared. So we've got 2 of these calculations so far, but again it doesn't stop there, because you could find that your first bag was more than 53, second bag was less than 53, and the third bag was more than 53. But if you were to do this calculation, it would still be exactly the same as this. So because these are mutually exclusive events, we would want to total them all together. So we've got this calculation occurring 3 times over. Alright, so all I need to do is multiply this by 3. So if you work that out, you find that you get 0.01249 and so on. So if we were to round this to 3 significant figures, say, it would be 0.012 to 3 SF. Okay?